All right, here's our lesson 15.3 to 15.4, graphs of exponential functions. So what I want to talk about first is just what the graphs look like. So in general, you may want to take a note that graphs of exponential functions get large or small very quickly. And we've talked about that before, but you can kind of see that in some of these examples. So like, for example, on A and C, notice that the graphs get really, really steep really quickly. The same on B, or I guess kind of opposite. On B, they get really small really quickly. On D, it's kind of a little bit different because when it's going down in the negative range. All right, so if we try to match these, some things that I want you to notice, so I'll just tell you the ones that match up. So 4 goes with D here. And the reason, you may notice, the reason that 4 is going to go with D is this negative sign. It's the only one that's negative, which means it's going to open kind of upside down. So it's going to go down forever. So you may want to make a note. We're just going to take some little bullet points. If there's a negative in the front, it goes down forever. All right, pause and write that in your notes. Okay, so we said that 4 went with D, so we've taken care of both of those. And then some others that I want you to notice, 3 is going to be B. And the reason for that is our pattern, notice our pattern is a decimal here. So if you have a decimal as your pattern or a fraction as your pattern, remember fractions for the pattern mean division, and division is going to make it smaller. So this one is getting smaller because the pattern is division. That's something that you all recognize already. And then A and B, we're going to notice kind of the difference of those here in a minute, and then we'll kind of come back to this when we start class tomorrow. Okay, so we've just got 2 examples. Here is example 1. They're going to ask us to graph this without a calculator using the domain that they give us. So remember, domain, those are my x values. And really, that is just going to tell me my terms. So I'm going to take a second and kind of make a table. This is very similar to what we did today. So my table is, I've got -1, 0, 1, 2, 3, and 4. And if you remember, my function rule here actually tells me the starting point and the pattern. So remember, this number is my start, and the 1/2 is the pattern. That means my starting point is at 3, and mathematicians are weird, remember, they start at the 0 term, so my 0 term is 3, and my pattern is 1/2. So since my pattern is 1/2, that means I'm going to be dividing, that's the same as divide by 2. All right, so I'm going to divide these by 2. Well, if I divide 3 by 2, that gives me 3 over 2. And if I divide that by 2, I get 3 over 4, and 3 over 8, and 3 over 16. Notice how the bottom number is just multiplying by 2 every time, since it's 1/2. And then if going forward is divide by 2, then going backwards must be multiply by 2, which means my first point there is going to be 6. And to be able to graph that, we literally just take the points that they give us and put them on the graph. So -1 is at 6, 0 is at 3, and then 1 is at, so half of that, 3 over 2, we're just cutting that in half, that's like 1.5, and then half of that, and then half of that. So you should notice we're getting really, really small here, and we're not going to connect them because they give us separate points. So do not connect. And remember, we call this discrete when they're not connected. Discrete. We haven't talked about that word in a while. All right, if you have questions, I want you to write your questions in your notes for this example so we can talk about that specifically tomorrow. All right, this question is very similar, except this time they don't give us a domain. So if they don't give us a domain, we're going to use a domain of all real numbers, which means we are going to need to connect our points in the end. So if we want to connect them, that means we're going to have a continuous graph. Continuous, connected. All right, so we're going to kind of start the same way by making a table, and then we'll just connect our values in the end. And I'll start with 0. Well, actually, I'll put 0 in the middle of our table. So let's do -2, -1, 0, 1, 2, 3. So remember, mathematicians start with 0, and our starting point is this 3. So start as 3. And then 4 is our pattern. That means I need to be multiplying by 4. So if I multiply by 4, I get 12 and 48 and 192. And then when I go backwards, remember, to go backwards, we've got to do the opposite. So to go backwards, I'm going to have to divide by 4. And since that doesn't divide well, I'll just write it as a fraction, 3 over 4. And if I do that one more time, I get 3 over 16. Now, if you need help with those fractions, put a little star in your notes that says you need help with the fractions. Okay, so my starting point here, remember my starting point, 0, is going to be at 3. Ooh, they don't make that easy to graph. And then at 1, we're going to be at 12. And at 2, we're going to be at 48. Oh, so this gets big really, really quickly. Okay. And then I can't even fit 192 on the graph. And if we go backwards one, remember, it's still just going to get really, really small. This time we want to connect because they don't give us the domains. We're going to do all of this. So I'm connecting there. And we'll try to talk about range here in a little bit. We may wait and do domain and range just a little bit with your calculator tomorrow. But make sure you understand the concept of where do you get the starting number and where do you get the pattern every single time.